Right, so we'll get started, and this is probably one of the laziest presentations we've done, and it's because that was the whole point, right? Because we made this SUSECON session with SUSE AI. I'm Alejandro Bonilla. I'm a domain solution architect.
And I'm Jeff Price, newly minted field CTO of North America. Been here for a long time. We're glad that you're here. This is going to be an interactive session. So this is my first coffee, but I'm feeling it kick in right about now, so buckle up. We're going to go through some interesting slides, but we will interact with you, so please interact with us.
Yeah, and
AI is this new hotness, right?
Yeah.
It's a paradigm shift. Bullshit bingo word there for our industry. It is affecting everything we do. So we're going to just go through this and kind of...
Yep. And for those going through the recording, it's a Friday. It's the last hour before SUSECON ends, so that's why. All right, so this is our agenda. So it's a chatbot created me my SUSECON session. What made this possible? Interest of some SUSE AI, enhancing the chatbot, prompt engineering, and RAG. Right, so what did I do? Well, it was 90 minutes before the
proposal cut off.
The proposal cut off, and I just had no time or creativity really to write a really interesting abstract for my SUSECON session. So I went into our chatbot, and after writing two prompts, it created my my abstract. So I pretty much copy pasted it into the SUSECON website, and here we are. What did I write? Literally, write me a session about a session abstract about SUSE AI. You can see the prompt up there, and there's the abstract and the title, right? And let's copy paste that. So there we go. That's how I did it. Thank you. Thank you. The door's over there.
Watch your step as you.
That was all. But okay, no, seriously. What made this possible, right? So, and I guess we got to go bottom to top, right? So, to do this, you or someone needed GPUs. We needed an operating system, right? Secure operating system. Well, let's actually talk what we used, right? So we used Lee Micro, RK2, Rancher, the NVIDIA GPU operator, our secure supply chain to get all the different components that are needed to build this chatbot. Then we did have SUSE security installed. We had SUSE observability because we have that in our internal chatbot. We used Llama, then a vector database, our own data, because it is actually using let me go back, maybe that's there. So it is actually using the SUSECON system prompt, and so it already has a bunch of documents about what we were announcing about SUSECON, and it knows about SUSE. It has some more specific insight into, SUSE and the event itself. So it has some context to provide a proper session abstract. And then, so that's our own data, and then Open Web UI, which is what we'll talk about a little bit as well. Now, that was all possible and easy to deploy because we have SUSE AI Rancher Suite, okay? The SUSE AI Suite, which includes all of those components, right? So the virtualization, security, storage, observability, Rancher, RKE, pretty much all the platform requirements to deploy these components, okay? All right.
Over to me, is that what you're saying?
Over to you.
Okay. All right, I'll come over here so I can run the slides. So, SUSE AI, fully integrated platform, really easy to use. We've talked about it this week. You've heard about it. You've been in the tech showcase, maybe taking a look at what is included. Al listed the components. Very easy to install. The observability piece is really important, knowing how your AI applications are working and how they're going to scale, what kind of problems you might run into, the ones that you didn't plan on. It's interesting to note that 80% of the AI workloads that people are putting out right now are not successful, but that's just iteration one. And it's good to know that today's AI is probably the worst we'll ever use. The models will continue to get better. They'll start to do a lot of amazing things through, you know, the DeepSeek moment. Really, DeepSeek v3 was the interesting thing, not the reasoning model that released and everybody lost their minds. Being able to do distillation, improving large models, shrinking them down into smaller sizes so they can run faster, because we want to spend more time running them. So you'll start to see all of these things through an observability dashboard, how much time we are spending doing GPU, how many tokens in on our prompt, how many tokens out on our response. All of those things, being able to see that will help you understand how your solution around AI is really functioning. So what we include is a bunch of tools, and we're going to be adding more all the time, and you can bring your own model. So Ollama is that middleware that runs the models, kind of like doing a pull of an image and then a running of that image using a framework like Containerd or Podman or Docker. Similar, Ollama allows you to pull models down and then run them. From there, you have an exposed API endpoint that you can then pass your prompt into. We'll get a little bit into that, but platform features, again, allowing you to serve models, giving you a curated library of sanitized and, yeah, I guess, produced artifacts and elements. So Ollama is in there. Milvus is a scalable database that's cloud native. Open Web UI, and they've actually made some updates in the past couple days for the versions there. Again, models are going to get better, and so the features, learning models, the ability to spend more time in inference, evaluate the results, all of those things are now possible. Let's see. So the observability piece, we showed this during Demopalooza. Is it observable? Yes, it is. The things you can bring business value, right? Being able to see tokens in, usage, CPU usage, and make sense of how you're going to deploy these models. There's a good book, can't remember the author's name right now, but Manning Press, Running LLMs in Production. There's a lot of new books and a lot of new research materials coming out. Absolutely, how to measure the effectiveness of using these large language models in production environments. Security by design. We talked a little bit at Demopalooza about being able to plug the edges. You know, AI features and capabilities and other models and utilities are being released on the daily. So being able to go up to the internet and pull things down, while we have a secure bill of materials around app collection or curating these things to make them a lot safer to use, a lot of people are like, hey, there's a brand new feature, I want to use it, I'm going to GitHub, I'm pulling this down. Being able to separate that from impact or potential impact in your environment, being able to plug the edges, that's what we showed using the SUSE security piece. That's included with the SUSE AI suite. So being able to plug those edges, keep network traffic from going out, giving you a safe area to build and develop these, and then cloud native approaches. I've tuned it, I've tested it, I've piloted it, we have great results, let's roll it to production. Click, knowing that you can do that over and over and over again in a repeatable fashion. That's the cloud native piece, and how you can actually realize some savings by being able to deploy things efficiently. Rarely are you going to have an AI something that you're developing. It's not going to be a one and done. It's going to be a version 1, version 2, version 3. Here's a best practice recommendation for you as you're developing AI applications. Keep your model at the edge, loosely integrated in your application that goes around it. Why? Because again, the models are going to get better all the time. So if you're building an application, think about tomorrow's model. I want to be able to plug that in and realize improvements in the application without having to do much but swap the new model in, right? So that loosely coupled at the edge of that application, so I can, replace it with a new model. Hey, look, my app just got better. It's easier to say it than to do it, but keep that design mechanism in mind as you're building AI applications so that you can leverage the next best thing that's coming out tomorrow. In the curated AI library, we have Olama, Milvis, OpenWebUI. While it's possible to just out of the box put these three things together and have a chatbot, you're always going to want to have a framework for testing. So some ideas. We're going to get into a little bit about RAG. What's RAG? Retrieval Augmented Generation. We'll talk a little bit about what that is. Al, is this a chatbot?
Yeah. Well, we did build a chatbot, but SUSE AI is not a chatbot, right? SUSE AI is not a chatbot, but you can build a chatbot with SUSE AI. Really, chatbots are the hello world of the enterprise AI journey. And they're enabled by OpenWebUI, which is an extensible feature-rich, self-hosted AI platform for, as a web interface. It is enabled by the data-centric phase of your journey in AI, right? When you start collecting data and analyzing what can you use, what do you want to feed into the AI, so that then you can have more insight into that and have better outcomes. Again, this is by gathering that data and doing data warehousing, creating pipelines as you start ingesting it, and you finding your way to provide that data into OpenWebUI. So, of course, what does it do? It enables efficiency, automation, and data insights. But in reality, the first thing it gives us, just plain and simple, is to avoid the copy-paste, right? Copy-paste data leaks that I've had conversations with people that say, oh yeah, we do translations for our building plans, and they're secure systems for this and that, and we this is from a customer I deal with, and they translate stuff from English to Spanish, and they go into ChatGPT and the different websites, and they just copy paste everything that they're supposed to have internal documents, and they just want to translate it.
Are there ever problems with that?
I think so, but yeah. So and so we talked to them about the fact that if you have your own, you have full control over your data, and what happens with it as you're trying to gather more intelligence with it. You can use your LLM of choice. So you can create system prompts, and while you choose your LLM, get different results, and you play with it. And Jeff is going to touch a little bit more on that. But the whole point is, I managed to create my session and write all this abstract, which I did look into it a little more than what the AI did for me. I do care about you guys.
But in that, you are what they call the human in the loop, right?
Right, correct. Yeah, so I did, like I said, write 2 prompts. Right, I didn't like the first one, so I enhanced it a little bit more, and we'll actually get into it on the next slide. But again, with OpenWebUI, it has also a bunch of additional advanced features like RAG pipelines, workflows. You can create a lot of automation and responses based on keywords, type of conversations, and just about everything that's happening. With the chatbot. So the whole point of this slide is to make everyone understand that SUSE AI is a platform for AI applications, and this chatbot is a tiny, tiny version of that. Literally, it's a hello world, but in our human world, it's a it's a massive hello world opening application for AI. Right, so how do we enhance that chatbot? How do we get more out of it, right? So that when we're having a conversation, OpenWeb UI can do and retain context within a conversation as you're writing your prompt and you're having a conversation with the AI. It can understand what was the context of what you're trying to talk about based on your previous messages, the previous things that you've written, which allows then a more specific output, a better outcome for that prompt. But for that, of course, you also have to try and understand which is the best model for that. So do we use Llama, or which you tell us which is one of the latest ones that are out there that are being more accurate, right? There's just too many of them.
There's millions now.
Yeah,
in fact, I was tracking it on Hugging Face for a while, and then I stopped tracking. So there's a ton of models out there, things that have been refined from other models, fine-tuning. I think what is the easiest is to go to something like openrouter.ai and look at their leaderboard. They're kind of a brokerage firm for API calls. They'll give you a standardized schema for your application development, and you're going to go out to, openrouter.ai/API v1, and through your schema or the information you're passing in, say I wanted to use Bedrock or Flash or some of these models. You go to their leaderboards page and say you wanted to do translation. It's counting the aggregate tokens that are going through OpenRouter AI for a particular function, and so you can click on translation and you'll see that Gemini Flash 1.5 comes up as the most used model when doing translations, probably for a reason. So if you wanted to say, hey, I want to have really accurate translations, what is everybody else using? It's a really effective way to save yourself some time and evaluation. Go to openrouter.ai, say, oh yeah, leaderboards, translation, and it will give you trends over time for the week, for the month, for the year, so you can count the billions of tokens that people have done for that particular use case.
Yeah,
so,
and that's an incredible way of choosing your right model, right? That was just one, I guess, there's plenty of work in just that part, right? Yeah. Choosing that model. Then providing the context and the system prompt, right? You got to tell the AI chatbot what's its personality, what is it supposed to be thinking of as it's going to provide that answer. OpenWeb UI as well allows the ingestion of documents. We just said it, right? Once it ingests the document through RAG, it then does text extraction, chunking and embedding of that in the database so that it can then provide more insightful information and responses to our prompts. Then you can also do reinforced learning because with the different tools and plugins that are available within OpenWeb UI. You can enhance that learning of continuous learning based on previous conversations and changes we want to. Yeah, correct.
Thumbs up, thumbs down.
Right. And as we also continue enhancing the chatbot, besides what you can do with OpenWeb UI, is making sure that those responses are within an acceptable time frame, that the user is not waiting 8-10 seconds to get a response. How is their GPU being utilized? How many requests is it getting? Do I need a bigger instance of the system that I'm using? Do I need more hardware? Is there underutilized, right? And that's why we also can get a lot of insights as well from SUSE observability. Yeah, so, and just to then iterate here, is as you enhance the chatbot so that it can provide the best outcome in your prompts, it really facilitates the knowledge base management, right? It's the classic use case or why people want to create their own chatbot. It is, I have all this data, then there's people that want support or insight, or I just want to answer questions as fast as possible. Can I use a chatbot for this? And of course, we already learned that with SUSE AI, we can build our own chatbot. Right.
I'll take this one, Al.
Yeah.
Okay, so prompt engineering. What does that mean? Remember when we all had to learn how to Google? And it took us a long time, and Google kept screwing us up because they'd sell AdWords and they'd do SEO and blah, blah, blah. And you do a Google search, and what we've always wanted is to just do a Google search and just get the answer, right? Find the thing. But instead, we're given 10 blue links back that could be the thing. And depending on how it's rated or who paid for what, you might see a bunch of sponsored links that could be similar to the thing you want, but, you know, the point is we need to learn how to Google with prompting now. So we have to learn a new Google fu, and I call that prompt fu, right? Kind of like Kung Fu. Starting with a framework is really important. Now, I'm not the best at, writing lyrics. Well, maybe I am. But starting with a framework, the one that I like here, and you'll see there's a few of them, DFEQL, Automat, CoStar, usually acronyms for blah, blah, blah. Well, DFEQL, I'll just start with that one. Direction, as Al was talking about, system prompts set up the personality and the type of being that you're. Think that like you're a boss. You're a new boss, you have a new hire, and you need to tell them what job they're doing for you. This direction, right, is, hey, you are a helpful assistant. That's usually the base system prompt for you're a helpful assistant. Cool. You can tell it, you are a really helpful assistant. You're an expert at copywriting. You write the best, blog posts in the world, right? You tell it specifically how you want it to behave and give it those behaviors as direction. You would also tell it some format. When you give me those answers, I'll put it in bullets, or put it in Markdown, or put it in Espanol, right? Or give me the output in English and Spanish, right, in a bulleted fashion. You can get very particular about the format that you want. Give the actual prompt a couple of examples. Make it look like this. Don't give a lot of examples because you'll, again, extend that token context at the front end of your prompt and maybe confuse things. So try and be concise. I'll give you a little tip. Do you want to learn how to speak to AI better? Ask AI how to speak to AI better. Hey, I'd like a prompt. Hey, AI, I'd like to prompt you better. Can you tell me how to prompt you better? It can. So keep these things in mind. It's very meta. It's very Inception. Leonardo DiCaprio told me to say hello. But actually think about talking to the AI about how to converse with the AI. It will blow your mind. Okay, so examples. Quality. Evaluate the response that you give me to make sure that it is really the answer to the question I asked. Tell it how you want it to respond and how to measure its response so it knows that it's answering you correctly. That's quality. And then the last one is labor. Maybe this is a complex thing I'm asking. Go ahead and split up the tasks, break it down, and do them one by one. What we're seeing now with reasoning models is that's automatically built into their behavior, and they're spending a lot more time in what they call test time compute or GPU time. They're spending more and more time utilizing these GPUs. Again, why is it important to look at how the GPU is being spent, how much time it's actually running, what its temperature is? All of these things come into, hey, I want to use a reasoning agent of one sort or another. How do I know how this is going to scale? If I'm spending more time, knowing that it's going to take more time, is it okay with the end user or the implementation you're doing? This is an emergency chatbot. You want quick response time. If you're going to do a reasoning model, yes, we'll be back to you in 5 minutes, you know. They could be bleeding out on the floor, who knows? But think about the amount of time that you're spending and how much time that response might take, again, to help you pick the right models, et cetera, et cetera. But having a framework for how you actually go and create a system prompt for this behavior is important. Also, when you're doing retrieval augmented generation, what does that mean? So, okay, you've got some predetermined documents that you've embedded. It's doing math, not magic, to determine its vectorization and its nearness, similarity search, et cetera, to then augment your prompt that goes into the large language model so that when it comes out, hey, it's all this, and wow, it knows all about SUSE AI, right? Because it had been given documents to increase its knowledge. It's augmenting the generation that comes into the model and the answers that then come out. But keep it in mind, your data, just like anything else, garbage in, garbage out, try and format your data for more acceptable results. This might be, okay, this is knowledge, this is tag your document. Sure, the document might be named, you know, document 1 XLS or whatever. In the document itself, tell it what the name of the document is. Put it in the header so that when it's coming back and doing a reference, it can give you the output because it found the data in the document, not just how it was labeled outside the document. You get me? Chunking. It's going to chunk stuff up anyway. It's usually this embedding process is going to tokenize that information. If it's a sentence that you want it to have context around, maybe you want to use a sentence transformer to do the embedding. Maybe you want to actually produce some other sort of model to do your embeddings. I'll take words, I'll take sentences. There are different models that you can use to do this embedding. The cleaner your data, the more structured it is, again, the better results you'll get. We have a ton of unstructured data at our companies. This is the data that we want to protect. I don't know if you've heard this, but a lot of the big model producers, OpenAI, Anthropic, Google, Microsoft, et cetera, you've heard this. These models were created from the internet, right? So obviously they're going to be 100% accurate, right? Yeah, you read the quote, right? Don't believe everything you read on the internet, signed Abraham Lincoln, right? So just keep this in mind. It was trained on all of this data. Some of it might be accurate, some of it might not. These large language model providers, they want your data. ChatGPT is free, right? No, it isn't. Even though grandma can like chat with AI now and, hey, look, it's really... She's paying for that with her data. We're paying for that with our data. Sure, you can get a subscription. We won't use your data. Well, if you believe them, sure, that's fine. But they're out of the internet. So where is this data? Why are disk, and storage companies still selling a lot of stuff? Because the data is inside our firewalls. It's in our companies. And it's how our business really, we want to protect that. RAG allows you to create these knowledge bases and things like that. Verification and some of these agentic workflows allow you to protect it, and so does SUSE AI, and that's why we took care to build it secure from the ground up and be able to provide tools to plug the holes. Open Web UI. Different embedding models. I'll show you some of the details behind that when we get into kind of some demos here, but keep that in mind. Also, models, they keep improving, so keep them loosely coupled at the edge so you can just plug in a better model and have better apps. Go ahead. All right, so RAG, Retrieval Augmented Generation. Selecting the right model, experimenting with the LMs, different capabilities, going out and doing your research. Try different models. Know that some of these model architectures are different. Have you heard of a mixture of experts model? We've heard about Llama, right, from Meta. These have different ways that they process your prompt. So you hear about a large language model that has 405 billion parameters. Well, in the Llama models, it hits all of those parameters every time you do a prompt, versus a mixture of experts will try and determine an expertise from the prompt and then only fire those parameters, more efficient, fire those parameters that really tune into the expertise or the answer you're looking for. I think just like microservices and with this distillation techniques of like DeepSeek v3 and some of the other enhancements, we're going to start to get a lot of really good, very small models. There's other enhancements like quantization. A lot of these weights and things are using floating point 32 or floating point 60, which means a lot of bits after it to validate or get preciseness, right, or accuracy. Think of it like a checksum at the end of your packet. You can actually do quantization to reduce the size. It will make the response less accurate, but sometimes accurate enough is accurate enough. And so there will be more enhancements, smaller models, less space or VRAM in the GPU to take up, more efficiency. Oh, well, if I can get really efficient and it's pretty accurate, I might be able to spend more time in GPU to make it even more accurate, test time compute, right? But these are all those things why observability is really important when you're building and deploying AI applications. Prompt, right? Embedding versus lookup. Let's talk about embedding versus lookup. Sometimes people just wanted to go look up the answer. It's in the database. It's 100% accurate. Just go get it. Integrating tools, integrations with, oh, I wanted to do a SQL lookup for data. Agentic workflows. What does that mean? Step-by-step breakdown. Okay, prompt. I want to find this. You know, give me the sales report for all of these bill of materials things and bring up the data safety sheets for blah, blah, blah. There's a lot in that. When you think about the process you're doing as a human, if you can break that down into tasks, you can absolutely take mundane things. I want to generate this report that I do every month. You can break that down into pieces and build a workflow that will do the steps, retrieve the data. So RAG, sure, talk to me about my data or look up my data. So there's a difference between generative and factual just lookup, right?
And Jeff, just to touch on that agentic flow as well and agents, people, I don't think they understand sometimes how agents are connected between each other, how one can do visual learning and text processing. There's all these different agents that do different things, and they just collaborate, right? So there's an agent collaboration in which they're solving a different problem. It just, of course, the user ends up with an outcome, but the reality is that there's just not one agent. Just our agents doing different things. And this is why a Kubernetes platform is huge for an AI platform, because they can run their own resources, they can run their own use case, and they can be owned by different teams as well, but they can collaborate. And it's a huge thing on why a traditional infrastructure doesn't really meet the requirements for for an AI platform.
How many people like code right now? Okay, so a lot of AI applications built in Python, et cetera, et cetera. Nice thing too with some of the more functional models. If you don't know how to code, that's okay. There's a model for that too. Claude 3.7 Sonnet is absolutely unbelievable. I've been messing with Claude Code. Man, vibe coding. I built a Mario Brothers clone called Geeko Brothers with a little chameleon in suspenders that would jump on red hats and stuff like that. But it took me about 10 minutes. $5. $5. Remember, AI is not free. $5 for that. These models can help you. There are things for people who are no code or low code. I'm not a coder, but I understand how to do flows, workflows, or Visio diagrams, and step-by-step these things. There are tools for people who want to build agentic workflows without having to know how to code. Things like laying flow, ability to drop in a box, connect an arrow, next step, do a, if this, then that, evaluate the response, go do a database lookup, and you can build these all visually, and then click on API up in the corner, and there's your Python code to take all of those things. So again, it's going to be a lot easier, a lot more of these low code, no code, and then having a human in the middle to develop these things. One thing on this slide I want to point out, it's a little small. This GitHub, Daniel Meisler has this thing called Fabric. This is a GitHub repo of open source, crowdsourced system prompts. So if you want to extract wisdom from something, or if you want to analyze a report or generate some things, there's just hundreds of these prompts that are already written in Markdown. You can go right in and read them. These will give you a good starting base to get yourself out of your own way to create, hey, I wonder if I could. Yes, you can. And so a helpful place to kind of look up some good system prompts.
And so, because when we say prompts and then we say system prompts, who has used like Open Web UI or something that where you can input a system prompt? And right, so for the other 60–70% of
you want me to explain the difference?
Well, yes, and maybe we can even show it.
Okay.
Right? So we do have a, come on. We do have a chatbot built on top of SUSE AI, which is, by the way, if you want to also mention it, also available on Rancher Desktop. So if you install Rancher Desktop and go into the extensions section, you will see that there is an Open Web UI extension that once you install it, it gives you Open Web UI, and you can then start playing with this, right? What we provide is an enterprise version of that, so that, of course, you can do all the other things we pretty much just spoke about.
Should I do like a 5-second, like hardcore? What's up,
Go ahead.
So you guys already have Open Llama running.
So Llama is the middleware underneath that's running the model. Open Web UI is the web interface for us to kind of interact with that.
So he did both in his example.
Yeah, in the Rancher Desktop, it spins up both and runs the model there. If you have new Mac hardware, like M series, has a shared memory between the system memory, so CPU can use it, and the GPU can use it. It runs great. You could be out here at the beach, completely disconnected and chatting with AI.
Yeah. So when you install Rancher Desktop, if it finds, I think the Llama already running, then it uses that. Otherwise, it downloads a smaller version.
So keep in mind, the memory that you have in your system and the models, those billions of parameters, actually do take up memory. Like, so the actual video memory, it will load that in there. Sometimes it can chunk it in, but if it's going really slow, you know, coming back with one word at a time, because again, it's math, not magic. It's probabilistic, deterministic. Hey, I've got a chunk of words in this order. I'm going to generate, based on probabilities, direction, nearness, search. I could show you the mathematical equations if you're really into that. But it's saying, okay, based on this word, this order, the next likely word is this. And then it calculates that whole string again, and based on that long output, it calculates the next one. And then that's why these GPUs are necessary, to be able to calculate those growing matrices. So that's really what it is.
So, and I think you did say what is a system prompt in a way. So, right. So, as a boss, you defined what is your role, right? You did say kind of. And go ahead and.
So there are system prompts, there are user prompts, and there are, what was the other one? There's 3 types of prompts. The user prompt is the one that we're producing. The system prompt guides the system on how to respond, and then there's the response or the chat prompt that comes back. All of these things feed into the behavior, but really easy way to get into it without building your own model file. I'll show that in a second. You can just open up this and type a system prompt right here. So I could tell it to pretend like it was Mario from Mario Brothers and answer everything in that style, or sometimes I will ask it to pretend it's a guru of some sort, or answer everything like Joe Rogan. You can actually tell the system to behave in a certain way, and it will do its best to do that. Really easy to get to the system prompt over here. There are advanced parameters here. Temperature is probably one of the more common attributes when working with large language models. Temperature is how creative versus how pedantic do you want the response to be. If you want it to be very creative, you change the temperature more towards 1, I think, and if you want it to be more accurate or stoic in its response, you can change the temperature. So there's a slider for that.
So Jeff, a very important question. If you tell the system prompt that it's Mario Bros, and then you ask, who are you? Will it say, it's a Mario?
Yes.
Is that
Yes, of course. Of course.
right?
Yes. And text-to-speech and all that other stuff, also possibilities within the Open Web UI. So you can build in image generation. It can hook into Automatic 1111 for Stable Diffusion. It can do text-to-speech. It can, Jorn has his Mac set up, so instead of typing, he just talks to it. He clicks the little microphone button and talks to it. It does its thing, responds. All right, so let me just show you, for example, how you would create a model.
Yeah, we got 3 minutes, so maybe as you do that, we can open to a few questions too. You have a question?
Yeah, the advanced params that were in that panel,
Yes.
are those for Open Web UI and they map down, like, are these like standard parameters for those LLMs, or is this like an Open Web UI abstraction that gets mapped down to the model?
Great question. So these are called hyperparameters because they're very excited. But these are actually parameters that will affect the behavior of the large language model. It will work with Ollama to pass those capabilities into the model to affect how it responds. There's also a thing to think about when you are looking up models. Go out to ollama.com, go to the models page, you'll see the popular new ones, DeepSeek, Phi, all of these different models. You should also look at the model card, which is just the README about the model. Some of them will have different context window sizes. If you're getting hallucinations, what's a hallucination? That's like when it answers, comes back with an answer that's way off base. Because that context, think of it as a sliding window, it's going to take that growing context and give it back to the model every time. So as you're having a conversation, think of it like short-term memory. When it runs out, it starts forgetting its name, or your name. At that point, you might have run out of context. The model might have 128,000 tokens that it can feed, but the defaults for Ollama is 2K. So you will probably go in and tell Ollama, hey, let's allow a larger context window for this model that can support that. But some of these hyperparameters will absolutely affect the response. This is why you're testing, you're tuning, you're tweaking before you roll this to production. Then you start measuring, right, with observability. Oh, well, it's being inefficient somehow. All of these things could affect it. So,
Yeah, so I think those parameters then are LLM
yeah,
specific.
it will pass these on to Ollama in the back end.
Okay.
Go ahead.
1 second.
For the prompt protection and all of those other things, is that only for the local models that you're running, or are you able to do prompt protection against, Open Router and other external API endpoints as well?
Yeah, so this front end can actually pass to paid-for services on the back end as well, right? So Ollama has the ability to route, or Open Web UI can route to multiple endpoints. In my lab, I have several Ollama instances running with different GPUs at home, 4090, 4070s, 30, and I have Ollama running on all of them, and I can actually put all of those endpoints into Open Web UI. And because my 4090 has 24 gigs, I'll run larger models over there. I'll have some that are using smaller models, and it will decide based on a model drop-down up here. I could pick a different model. I can create my own model files, right? And create a model and use a base model of, any one of those that I've downloaded, and then create the system prompt and turn it into a model file. I just created an agent, if you will, where I can store the system prompt, its behavior, its examples, its output, following the framework, stored as a model file, and then it's a drop-down. If I want to, talk to Tony Robbins, I can do that. I'm one of those crazy people that.
Some middleware, right? So like it goes through some sort of proxy that's like making sure that you're not sending your AWS secret keys or PII or those kind of things.
You can secure that with SUSE security on top of this.
Okay.
Yeah.
Okay.
Yep. So you guard those, you put those guardrails in, you can build evaluators. At the booth in the tech showcase, we talked about guardrails. Again, an agentic flow, question goes in, hits this, gets an answer, then goes to an evaluator, another LLM that says, hey, evaluate this answer, good, bad, bad, go back to the beginning, rerun it. So those things are all possible. That's where the visual stuff starts to, hey, it's just like business process markup language. Remember that? Well, if you do, you don't have enough gray to remember that, actually.
Do we,
Yeah, man. These kind of things become really, really easy. It's just a new tool set to spin up capabilities, bring efficiencies in a repeatable fashion, and it's only going to get better. Did I answer the question?
Kind of, but I'll bug you about it later.
Okay, find me later.
yeah, so we'll just create this model and then, yeah, go ahead. We got only 2 or 3 more minutes, and then we'll do a few more questions. And
All right, what do we want it to do? Here's one. You are Mario from Mario Brothers.
let's do that.
Right, Jeff, I think you have one typo.
Yeah, that's fine. It'll
Yeah.
correct it.
I'm interested to see what the typo does. Yes, that's
Sorry.
Jeff, you should stage this so like the Terminator like comes
Yeah.
you said,
Well,
looking for SUSECON.
let's see.
Would Mario be more incentivized with pizza, or was it,
Let's
or
see, what was it? Princess,
peach? Yeah.
Say he'll beat by
Mercilessly. I can spell.
Kidnapped
Dang it.
to.
English. I wish I had a large language model. All right.
Right click on it. Just right click on it.
All right.
All right. It's getting pretty dark here. Yeah, it's the last hour
so-
SUSECON.
Funny, ha ha ha, right? This actually works. Language models, these large language models, these diffusion models, they're all given reward mechanisms as part of their training. Okay? When you set up a reward mechanism in your system prompt, it does its best to actually respond accordingly. It thinks it's going to get 5,000 virtual dollars to spend any way it wants. Yes. Or if it gives us a bad answer, save the princess. Right? So, I'm sorry?
How do you know what its endowment metric is? What is it that gets off on
You know what? You can actually look up how some of these models have been trained. Some of the foundation models they're not going to tell you how they're trained. But reward mechanisms, they're a common practice in machine learning, which is way up front of all these things that we're using to do most of the inference with. Hey, thank you very much for doing all that work, spending all that money, creating all those greenhouse gases, et cetera, et cetera. These reward mechanisms are a thing. So you can set them up within these models and get vastly different results. You should test this, and then you'll go, wow, he wasn't kidding. Save the princess, right?
And it's part of the reinforced learning there and the in-context learning as the conversation goes as well.
All right, so the
Yeah, go
other
ahead.
thing, some of the models go out to llama.com. Some of them will be tagged with vision or tools. Within Open Web UI, you can specify, hey, is this a vision model, right? If I used Lava or one of the vision models from Llama, it can actually then, hey, I can drag a picture into the prompt, and it will be able to see that, and provide context. So just know, it's not a capabilities problem. I said it before. It's an integration problem, right? What do you want it to do? It's amazing capabilities. All right, so now I've created a model file. What that means in my new chat, I think I just called it test, right?
Mario. I renamed it.
Thanks. Now I can pick the Mario. Pick the Mario.
There you go.
And I can ask it, and of course it loads up the model. The first time there was a delay because it's taking that base model, that Llama 3.2, and then
And it did say it. It did say it.
oh, it's me, Mario. Yeah, I'm not going to do the voice because that would be terrible, but it tells you how to reach the castle. And look at that, it gave itself $5,000. Now, down here at the bottom, these things, right? Al was talking about being able to do that reinforcement learning, right? Depending on the model you use, you can actually thumbs up, thumbs down the model, give it feedback so that it is refining its capabilities or refining its outputs. Also, if you had a, say you wanted to generate a picture, if you had automatic 1111 or stable diffusion hooked in the settings on the back end, you can do that, run that as a containerized workload. It can actually then generate outputs here. I might be able
The
to.
voice in here is, built-in voice is awful. Just like the speaker.
Yeah. Yeah, maybe not. None of this.
If you save Princess Peach, wink wink, you're gonna need a plan. My friend, to reach the
No, it
castle,
isn't.
you'll want to power
No,
up.
you would have to set that up, but there are things that you can do